Hi guys, today we discuss a new point, Mendeleev's periodic table. I manually draw the table on this board. You are with the tech science, and right now we are discussing the point Mendeleev's periodic table. Okay, so now we discuss already Dobereiner triads law, Newlands octaves law, and this is what the third. Now it's time to discuss the Mendeleev's periodic law. What is the similarity in between these three? The similarity in between these three is that all these three scientists classify the elements on the basis of a fundamental property they consider as a atomic mass number, and on behalf of that they arrange the elements. But we know that Dobereiner triads law, when we discuss already, I given the link for the Dobereiner triads law in the description. You found that there are some of the drawbacks are there, and because of that drawback the Dobereiner triads law get failed. Same cases for the Newlands octaves law also. Now, what about the Mendeleev's periodic law? Mendeleev's periodic law having some kind of advantage as well as the drawbacks also. But before that, let us consider what is the basis of the classification of Mendeleev's periodic table, or how the Mendeleev classify the element. Now, the first thing, that is what the positive thing is, that Mendeleev was the first scientist who successfully classified the known element at that time. At the time of Mendeleev, total 63 elements were known, and all these 63 elements were arranged in a tabular format in the form of rows and columns. And here the rows are nothing but called as the periods, and these columns are nothing but called as the group. That's why I written like group number 1, group number 2, and so on. So the vertical column, they are called as the groups, and the horizontal rows, they are called as the periods. Same here also, Mendeleev considered the most fundamental property of an element is atomic mass number, and he also arranged the element in the increasing order of their atomic mass number. See, hydrogen atomic mass number 1, lithium 7, beryllium 9.4, next boron 11, then carbon 12, nitrogen 14, oxygen 16, and so on. So it proves that he arranged the element on the basis of increasing order of their atomic mass number. Before putting all these elements, all the 63 elements, whatever the known elements at that time, he considers some of the fundamental fundamental property. We can say that the physical and chemical properties of the element, and then he arranged the element. What are the physical chemical property consideration? Example, molecular formulas of oxides and hydrides, their melting point, their boiling point, density, and so on. And afterward he arranged the element. So what he found? He found that after certain interval, when he put forth the element in this tabular manner, what he found that after certain interval the physical and chemical properties of the elements are repeating after some time or after certain interval. So this repetition is called as the periodic trends. And on behalf of that, the Mendeleev designed the statement. What is the statement? The properties of the elements are periodic function of their atomic masses. This is the statement of Mendeleev's periodic law. What is the statement? The properties of the element are periodic function of their atomic masses. What does this mean? It means that when the elements are arranged in the increasing order of their atomic masses, the properties are repeating after certain interval. So this is what the structure of the modern periodic table. Now it's time to remember what are the merits of the Mendeleev's periodic table. What are the advantages of the Mendeleev's periodic table? As per the scientist who tried to classify the element, whatever the known element at that time, Mendeleev was the first scientist who successfully classified all the 63 elements known at that time. So as per my knowledge, we can consider this is the first advantage. What is that? Mendeleev, he was the first scientist who successfully classify all the known element at that time in a successful manner. Okay, so this is the first advantage. Now what is the second merit or second advantage? Whatever the information that is received up to the Mendeleev, so Mendeleev was not considered it as a final. Whatever the information, for example, Mendeleev changed some of the information, whatever the elements received till the Mendeleev's arranged element. For example, Mendeleev changed some of the information, or the we can say that atomic masses. He corrected the atomic mass. How? Beryllium. Example, beryllium. The position of beryllium in the old before the Mendeleev is after boron. But what happened here? At the time of before Mendeleev, the atomic mass of beryllium is 14.09. 14.9. The atomic mass of beryllium is 14.9. But Mendeleev, just I told you, okay, this is not the final information as per the Mendeleev consideration. So Mendeleev correct the atomic mass of beryllium and he conclude the new property, new atomic mass number of beryllium is 9.4. And that's why in the Mendeleev's periodic table, before boron, Mendeleev got the place. And when we arrange these things after before boron, then after the lithium, this beryllium got an accurate atomic mass number and the properties are suitable to the with respect to rows and columns. We can say that periods and like groups, etc. So that is what the second advantage. He correct the atomic mass of some element and he found that he is correct at that time also. Example, the atomic mass of beryllium was corrected by the Mendeleev. Before Mendeleev, the atomic mass of beryllium is 14.9 and now after he corrected to 9.4 and beryllium got the correct place. Okay, this is the second merit or the advantage. Now what about the third one? Third one is very important. What is that? In the Mendeleev's periodic table, if you observe some of the vacant places you found, observe this is for having the atomic mass 44, one more atomic mass having the 68, one more atomic mass equal to 72. So Mendeleev kept these vacant places in advance, although they are not yet to be invented. And these elements given some names by the Mendeleev, although by still they are not discovered, like Ica boron, Ica aluminium and Ica silicon. Ica boron, Ica aluminium and Ica silicon. Not only atomic mass number, but Mendeleev also predicted their physical and chemical properties which are yet to be discovered. And when these elements were discovered later on, the people compare whatever the predicted properties and what are the actual properties of the element. The people found that both are near to the same exact properties were predicted by the Mendeleev. So these left spaces, vacant spaces which are left in a Mendeleev periodic table which is in advance yet to be invented, and these are found to be accurate. This is what the third advantage we can say that, or the merits of the Mendeleev's periodic table. And last one, that is the fourth merit or the fourth advantage. It is that what about those elements which are not yet to be discovered? Suppose some of the elements get discovered and now it's time to place the newly discovered element in any table, not Mendeleev, in any table. And suppose you have to disturb the whole table, then it is not we can say that successful classification. Same case happened with the Mendeleev, but it is Mendeleev was the exception for that. At the time of Mendeleev, noble gas element, we can also say the inert gas element. In a modern table, it is called zero group element. They are not yet to be discovered. So when the zero group element, inert gas element, they discovered in a Mendeleev table without disturbing these element at the boundary of this table, Mendeleev automatically created the zero group element and they are placed at the end, at the boundary of this Mendeleev periodic table without disturbing the main elements in the Mendeleev's periodic table. So these are the four advantages of the or merits of the Mendeleev's periodic tables are there. Okay. Now it's time to remember, or it's time to discuss the drawbacks or the disadvantage of the Mendeleev's periodic table. What are the drawbacks? Because that the new law has been invented, that is the modern periodic law, and still we follow the modern periodic law. So there are 3 to 4 different types of drawbacks are there in case of the Mendeleev's periodic table. The first drawback is concerned with the position of hydrogen. Observe here, the position of hydrogen right now it is given in the group number 1, that is as just like a alkali metal. But remember, hydrogen resembles the property of both number 1 alkali metal and second is called halogen. So there is an confusion is there or ambiguity is there where exactly you have to place the position of hydrogen. If you place the alkali metal group, what about the halogen? And suppose if you are placing the position of hydrogen in the halogen group, then why not alkali metal? So this ambiguity didn't solve by the Mendeleev. That is what the position of hydrogen is not fixed or it is not solved by the Mendeleev's. Second is concerned with the group number 8 regarding the element like cobalt and nickel. If you observe regarding cobalt and nickel, here the cobalt and nickel, their exact atomic masses are like, for example, cobalt 58.93. The atomic mass of cobalt is 58.93 and the nickel it is 58.71. Then cobalt, although it is having the greater atomic mass as compared to nickel, so cobalt is placed before the nickel. Why? So such expression cannot be like cannot be explained by the Mendeleev's periodic table. This is what the second drawback of the Mendeleev's periodic law, or it is called as the table. What about the third one? Third one is regarding the sum of the elements in a Mendeleev's periodic table. They are kept in under the same group, although they are different properties. If you observe same group, hydrogen, lithium, sodium, potassium, means what does this mean? The elements which are in a same group, normally we consider it as they are same in properties, but group number 7 is nothing but like exception for that. How? Fluorine, chlorine, bromine, iodine, these are the examples. Fluorine, chlorine, bromine, these are the nothing but they are the elements. These are the elements which having the property of halogen. But in this, if you found manganese which is completely different than these three, why you have to place here? So position of manganese, with although the properties of manganese are totally different than these, then why you have to place here? So such expression cannot be given by the Mendeleev's. So number of drawbacks are there that cannot be solved in the Mendeleev's periodic table. One more drawback is there, that is called as the fourth drawback. And what is that? The fourth drawback is that the concept of isotopes. What is isotopes? Isotopes nothing but the elements which having the same atomic number but a different atomic mass number. So if you are placing the isotopes in a same group, in that case you have to find that they are different atomic mass number. And suppose you placed on a different atomic mass number, but because of different atomic mass number in a different position, then they are same in properties. So they are, so why you are not placing in the same group? That is also question. So how you can place the isotopes in a Mendeleev periodic table? It cannot be solved. Such questions are not solved by the Mendeleev's periodic table. And the last drawback is what? The elements which are arranged in the increasing order of their atomic masses. Here, if you observe the increasing order, you found that the increasing order is not uniform. This means that still there may be a possibility that in between the too much gap is there in between the increasing atomic mass number. So there may be a possibility that still these elements will not be discovered yet, and suppose they discovered, then how can you place in between these? This is also the question. So if the rise in the atomic mass number is not uniform, then there should be a possibility that this element may be found in the nature still, although they are yet to be discovered. So such problems are also not solved by the Mendeleev. So these are some of the drawbacks of the Mendeleev's periodic table, and because of that the new law has been invented, and the new law is regarding the modern periodic law by the scientist Henry Moseley. We will discover this in a next lecture. Okay, so if you like this video, please subscribe the channel and press the bell icon for the further notification. Thank you.